Hello and welcome back to the channel. This year, 2025, marks the 25th consecutive year of running of the Perth Electric Vehicle Challenge. This challenge tasks teams with competing with a manned electric vehicle that has 1 hour to do the furthest distance possible with 633 watt hours of battery capacity. There is no recharging available, and you're competing with other teams on go-kart style tracks with twists and turns, acceleration and braking, making it quite a difficult challenge to undertake. ReEnergise Racing, previously known as Kulo Motorsport, has competed in the challenge since 2009 and has learned a huge amount through all of those years. The vehicle that you see behind me is ReEnergise Racing's Quark vehicle. We first built the chassis for this in 2014, but over the last 12 years, we've constantly improved this vehicle with changes to the chassis, changes to the drivetrain, various different components that I'm going to take you through in this video so you can get an understanding of what's gone into the engineering of this vehicle. Over those past 12 years, this vehicle here has won us 4 overall wins of the challenge, 8 overall podiums, including a few second and third places, and 4 fastest laps with an average speed on a go-kart track of about 45 kilometers per hour. It's super fun to drive, and we will be making some improvements before the 2025 challenge, which I'll also go through in future videos. So let me give you a quick overview of the car. As mentioned, the Perth EV Challenge is primarily an efficiency challenge. You have to go for 1 hour continuously on the same battery charge. We've really prioritized over the years our front end of the car. So the steering, making sure that we can go through the corners efficiently, and also bearings in the front to ensure that we can go as far as possible with the least rolling resistance. These front wheels roll incredibly easily. The reason behind this is, first, we're using these Schwalbe Marathon tires, which we pump up to about 100 psi when we're competing on the day. Additionally, we made custom manufactured or lathed axles for the car, and just in here, the nut here has actually been lathed down to make sure that it only runs on the inner race of the bearing and doesn't provide any friction at all to the outer race of the bearing. So that axle there comes through to this side here, and it's solidly welded in, that bolt, into the axle. And where we space it off as well, just inside there, you'll notice that we've made sure to machine it so that the axle, the inner race, is once again only running on that washer that we've welded inside. When we move to the steering here, we use a tie rod type system. And the axle here is actually the bottom bracket from a bike. So where your crank pedals go through, we took that out, turned it vertically, and then welded it into this axle so that you've got a nice solid joint. And we can also make sure that there's very little friction when steering the car. We have these tie rod ends, which we've used some lock wire to ensure that they don't come out. And this is 16mm steel into which we've welded a nut so that we can rotate in the lock nut from the tie rod end. We then have these foam and carbon fiber constructed axle covers. And the axle, as you'll see, pulls off. And you can see it's really just some polystyrene foam with a single layer of carbon fiber that we've added onto the top. The axles are 40mm by 40mm square hollow section that we've cut and folded to bend into place. And then we have these reinforcement gussets here, because in 2017, we actually had the front axle of the vehicle collapse where it joined into the car. So these covers just slot back on. As you can see, there's a little slot there, and then press down to fit over the top of the axle and just make it a little bit more aerodynamic. Coming down the front here, We have a little cutout, once again, lots of lock wire on there, and that's covering up the end of this modified dune buggy steering. So everything's made modular on this vehicle. So we've got the space frame, the chassis, that doesn't change, but then all of the different components can be taken off. This isn't just mechanical components, but electrical components as well, which use these plugs to allow us to swap out components. But going back to the steering, what we're using here is a modified dune buggy rack and pinion, purchased off of eBay for about $100. So this entire section here with this universal joint running up the main shaft, and that second universal joint all came with this rack and pinion. Now the rack and pinion gives us a lot of control over the wheels. As I rotate that rack and pinion, or rotate the steering column, the vehicle turns in like that. By using different pickup points here, or attachment points for the steering, we can change the steering angles depending on which track we're at. In here, we've welded that onto there. And the dune buggy normally comes with large covers, but is a little bit heavier. So we cut these to length and made sure that we were only using the very central part of that rack and pinion. We also, when modifying the rack and pinion, cut out these slots from the internal rack to make sure that we were only using the length that we required. This is all mirrored on the other side, so we use exactly the same kind of steering mechanism, wheel mechanism, tie rod ends, and then the covers. And this is where our horn is mounted for the car. As mentioned, we use all of these IP67 type rated connectors. That goes onto the car, and then we can take this wing off by simply removing that connector. So that connector goes into the car, where we've used liquid electrical tape and some conduit to make sure that it's really nicely routed and no wires can get kicked by the driver or moved around. Heading back to the front of the car, you can see that the steering is held into place with a lock nut. And then with the throttle linkage, we have a little end stop that's welded down the bottom there to stop this from going too far forward. And this is actually a custom made and bent 16mm or 12mm, sorry, steel structure that acts as our accelerator pedal. It then pushes onto a 0 to 5 volt Hall effect sensor, which runs through to the front here and allows us once again to switch out this throttle assembly, which then that routes in and up the inside of these tubes. Up the inside of all of these tubes run a lot of the wires all the way to the back of the car. Now you'll also note that we have some foam in here. What we did was we attached the side structures first, so onto this frame after painting it. We then added all of the aluminium to the outside, and once that was in there and screwed on, we then sprayed expanding foam inside, which we cut the excess off. And this makes sure that the aluminium is actually stretched over the frame and doesn't vibrate around too violently when driving the car. Finally, up the front of the car here, we have our brake system. So once again, we actually use the tube here to run the brake lines all the way up from the front of the car, from this brake pedal, manufactured out of 12mm steel tube that we bent around. And we've just put the two brake lines into the same bit. That then runs through this bit here, which ends it to that tube. And then those brake lines run all the way up the side tube towards the back of the car. A few additional things to note about the front of the car here. So after we've seen that before, you'll see these unfortunately unburred drill holes. And that's so that we can easily access the mounting holes for the throttle linkage through the side of the car without having to take the top panel off. We've also put the felt on for the same reason as putting the foam into the sides. It basically stops the vibration of that top piece. And then you can see our battery. Our battery is mounted in the middle of the car, because it weighs about 8 kilograms. And putting it in the center here, even though it's a bit further away from the back, helps with the weight distribution of the vehicle. We use this strap to hold it securely in place, and then it's also mounted underneath with screws that come through from the bottom of the car that we've recessed or cut away some of the tube to allow the battery to sit right on the floor of the vehicle. We'll go around to the side and have a look in at the cockpit so you can see what it looks like for the driver from where they actually get into the vehicle. With the front cover back on again, we're going to make our way from the front of the vehicle where we've just seen the steering, the throttle and the braking back up to the main cockpit area of the car. Looking in from the front, we use this lightweight perspex from Bunnings as our windscreen on the vehicle, and this gets quite dusty, so before each race we make sure to properly clean it, and that's mounted in to this front rollover structure. So this here is 16mm steel, which was rolled and bent back, and then we have that forward rollover structure that provides a lot of support for the driver. Again, we built this quite heavy steel structure with the space frame, which you can see with all of the structural reinforcements inside, because in 2014, I personally was driving the car, had a massive rollover at Wundowie and ended up in hospital. Looking at the front of the car from inside, we've got the cockpit inside of this tube here. We've got the throttle wires and the forward horn wires running. And then we also have the internal driver controlled on-off switch. So that's the switch that provides the power to the Arduinos at the back that will give some of the throttle output to the controller. And we've also got some wiring that comes along to this point here on the inside and gives voltage to the steering wheel here. So we have a removable steering wheel, some 3D printed phone mounts for inside the vehicle. And this is also where we have our adjustable mirrors, which we purchased from a bike store and allows us to change the angle from inside the car. Looking inside, so the cockpit, to try and make it as comfortable for the driver as possible, we get them to sit as low as possible right on this structure at the bottom of the car. We've got the harness, which is a 5-point harness mounted all the way into the side of the vehicle with the mounting points down on the side tube structures. And then all of that comes in to hold the driver into this seat, which we cut out of polystyrene foam. So this is kind of packing foam that you would get when you get parcels in the post. We got large slabs of that and then cut those to shape. You can see that the wiring for the battery runs from the front here, and we have a separate on the battery on-off switch for turning the car on and off right at the battery. Then we have our steering wheel. This steering wheel gets its primary power from the car, so it won't run without connection to the car. And on this, we've got our regenerative braking, which is the red button. We have our brake strength, which we can set with this control here to change how much regenerative braking we're getting. And then this one here is our horn. So we use that to trigger the horn as we're coming up to traffic. Again, this looks very fancy, but it's actually 3D printed. Uses a $30 removable steering wheel attachment from eBay, and then an Arduino Nano from JCar, along with a couple of standard push buttons and a potentiometer. So that put together slides onto here, and we have a marker at the end that will show you when the wheels are straight. So that fits on like that and then into the car. Once again, we have our on-off switch, which is labeled over there. And we've made sure all of the surfaces in the car are nice and smooth, and there's nothing for the driver to be able to cut themselves on inside of the car. We also have our canopy here, which is quite basic. It's a couple of pieces of aluminium tube bent over to give it some strength, covered with aluminium, and then perspex covered into the inside. This fits in nicely like so, and then we've got some Velcro that holds it down when you're driving along. So that's from the front of the car so far, all the way back to the cockpit, and you can see how all of that steering linkage works. So far in the video, what you've seen with the steering in the cockpit all sits within our steel space frame that we've built in 2014 and then iterated on over the years. Where most of the improvement has come from on the car, however, is the drivetrain section at the back and all of the control electronics. So as you would have seen from the video so far, the battery is located in the front. We have our 36-volt battery. We also have our accelerator pedal or throttle pedal, the on-off switch, and then a wireless steering wheel. So ultimately what's coming from the front is 36 volts, 3 wires for the throttle, and then 2 wires coming towards the back for that on-off. And we're also supplying 12 volts forward to the steering wheel so that the Arduino there can be powered from the main car's power. Mechanically speaking, the back of the car here, we've been able to iterate on multiple drivetrains over the years by creating a modular subframe that sits at the back of the car. This has a bolt hole at the top that mounts to the top of the rollover structure, and then 4 holes here that allow us to mount it to the vehicle itself, straight on to the steel chassis. The rearmost part of the vehicle are these bike style dropouts, which are vertically mounted rather than horizontal as you might get on a bike. And that ensures that once there's weight in the vehicle, the wheel really can't pull out of it. We use V-type brakes, so these are our 2 independent braking systems on the vehicle. You can see them up the top here, and also mounted very close in at the back. And then these run into the side rail here, and all the way down to that braking apparatus at the front of the car. So I'll take you through a little bit of a tour of the mechanical aspects of the back, and then we're going to take some of these covers off and go through the electronics. Starting with the mechanical aspects of the vehicle, the bracing here on the subframe also acts as the main bracing for the rollover structure. That complies with the technical regulations, and then we have this 20 millimeter by 20 millimeter square hollow section that runs from the back of the car all the way out, and that's supported by some angle iron at the back. That all gets welded together and then holds in this 20-inch wheel, and we're using a Tioga Power Block 1.4-inch wide bike wheel. On the side here, we have 2 main side pods. This first side pod takes air from the front, which goes through the side and then over the top of the controller inside there. So we can take that off, and we have the controller inside, a contactor, which acts as the relay so we don't have to take voltage back into the car for the on-off switch. And then we've got nice braided sleeve that routes through the subframe and over to the other side. We keep the electronics modular so we can remove XT60 plug, pull it out, and then we can take the subframe off from the main car. The same with these brake lines, we can take those off and take the bolts out here for where we mount the harness straps, and the whole subframe will pull off the front of the vehicle. Right here is where we have our wiring coming from the throttle, providing the power up to the Arduino and also allowing for the on-off switch. And this goes into this control box here, which has a number of relays, Arduinos, and power regulators. We have a USB that's constantly plugged in so that we can program the car while it's running. And then underneath here, we have a vent that comes out the side and blows the hot air back. And then we have a radiator for cooling the electronics. And this here is the main part that's been behind our success over the last couple of years, which is our friction drive. So it's a brushless DC motor. It runs directly onto the wheel. And as the wheel turns, or as the motor turns, so does the wheel. Now, that relies on friction between the motor and the wheel, and that can become a limiting factor, which is why this year we're moving to a belt drive. So normally this whole back section would come off with the subframe, but taking it off individually means that we're going to have to remove this antenna here, and also remove some of these parts that typically wouldn't come out. This bit on the side here is so that we can charge the car without taking the battery out. So this runs all the way back through to the battery and allows us to charge the car at rest. We'll take this out because it's going to be separate to all of the rest. Behind the fuse here, this is our main fuse for the EV challenge, where it's easily accessible and where we can change it before it goes to the contactor. So we take that screw out there, and then this whole box pulls out from around all of these wires. Right, so now we need to remove our wire from down the bottom here. So we would remove our antenna. And this antenna here is for a Bluetooth connection to the controller, to our phone inside the car, so that we can have telemetry while we're driving along. Finally, I can remove the battery, the motor connections here, as we have an XT or an MT30, MT60 plug, and that will pull through. The sensor wires pull through, and now you can see all of the electronics in there. At the back of the car here, we have the two sides. So the right-hand side is the control electronics, and this left-hand side are the power electronics. Starting from the top here, we have our XT60 plug that connects through the firewall to the 36 volts coming from the battery. Off of the negative of that, we have one line that goes to the battery charger for the external battery charging, but then we have it come down with a common negative into the back of this XT90 plug. Coming off of this is our other wire, which acts as the common ground for the whole vehicle at the back. We then have the positive side come through to the top of the relay, and the way we've got it mounted at the moment is not the way that it normally works. So you'd have the positive come through, we've got another common 36 volt lead that runs off and goes over to the control electronic side. And then this wire here, this red one, would sit on the other side of this relay. Having this relay or contactor here effectively means that we can limit the length of wire for the control electronics, so that from the back of the car here, we've probably only got 10 centimeters of voltage here before it comes down into the XT90 and into the Veda electronic speed controller. So this is a VESC 6 electronic speed controller behind a custom aluminium plate. And that holds it onto a CPU cooler from a computer, which actively cools this controller while we're driving. Coming out the bottom are our 3 phase wires, and those go into a MT60 plug that goes to the motor at the bottom. We also have the motor sensor wires, but we don't use these as we use a sensorless control for the motor. On the controller itself, from the communications port, we've got our Bluetooth controller here, or Bluetooth antenna, that goes to the phone. Then we've got a USB port, which we use to program the controller, and we always keep this plugged in so that we can program the car without having to get into the box. And then we've got our servo control. So this is the throttle wire, and this throttle wire here goes across to the other side of the car to talk to the Arduino, and that gets a throttle signal from the Arduino, which is a modified throttle signal to the one coming from the front of the car. To turn this contactor on, it has a 12 volt coil. So we take 36 volts from here over to the right hand side of the car, convert it back to 12 volts and run that through all of the on-off switches on the car. which then trigger this contactor and give the voltage to turn the controller on. This also is a redundant system because we use the same on-off switches to control the voltage to the 5-volt converter, which provides voltage to the throttle and to the Arduinos, meaning that the car can turn on, but the throttle won't move the car forward or won't apply any power unless those on-off switches are turned on. Due to this redundancy, we will be removing this contactor ahead of this year's race and simplifying these electronics by removing the active cooling as well. Over on the right-hand side of the car, we have our main control electronics box. This one takes the throttle wires, the power wires for the on-off switch from the front of the car, and then put them down and into the front of this box. We also have wires coming in from the back, which is the back on-off switch, that go into this box as well. And then we've cut out a small bit so we can have the Arduino, which is an Arduino Uno, always plugged in to a USB, allowing us to program that Arduino without having to get into the box. As you can see in there, we've got a relay board at the front, an Arduino at the back. That's our Bluetooth antenna for the steering wheel at the front of the car. And then on the side here are 2 linear DC step-down converters. So this one takes it from 36 volts to 12, and that one takes it from 12 volts down to 5, which is used for the throttle and for some of the other electronics. The 12 volts goes into the back of the relay, as well as being used for the contactor. And the relay is used for turning on the CPU cooler, which we can see down there, and also turning on the radiator fan. The other relay that we use as well is for turning on the horn at the front of the car. All of this goes into 2 common voltages at the back here. So we have one that's 5 volt, and this one here is the common ground. So we have these 2 bolts at the back. One is for all of the common 5 volt circuitry, and the other one is for the ground as well. So we always have that reference. And that there is the main control electronics. It takes the throttle signal from the front of the car and also from the Arduino on the steering wheel and converts that into servo outputs that run the VEDA electronic speed controller, and then also triggers the contactor if we're using that circuit. And there you have it. That is the ReEnergise Racing Quark car. And there are a few other accessories, but we'll show those in a future video.